I hope you guys can see the screen now. Visible to everyone, and the audio is also clear.
Yes.
Okay, let's start it. So yesterday, with little hiccup, we were able to create the virtual network peering. The problem was to have the IP addresses, and then later on we found the overlapping happened, and then we had to create a new virtual network. Subsequently, we placed the virtual machine into the same virtual network. So that sorted out the problem. So that's what the lesson learned is network is utmost important. You can't take any chance because that is a foundation of your entire development, what you're going to do in the Azure. Okay. So today we are going to discuss Azure Firewall, right? In this, we are going to discuss each and every component of the firewall. What is the Azure Firewall all about? And what are the different components? How we are going to utilize it in our solution? And what all that we can play around with our network and how it is more fruitful. And we have been discussing that Azure Firewall is a kind of more granular compared to NSG. So today we'll see that. All right. So first of all, let's understand what is your take when you talk about firewall. What do you mean by firewall, guys, in a general term?
Block, basically. Maybe
Your voice is breaking, Arkin.
it will block basically. How can I say? Maybe it's unnecessary data or unnecessary um, um, unnecessary packages. Maybe I'm wrong.
Right. So it's just kind of blockage, a firewall is a kind of a fire. It's a kind of, a protection, or it actually protect your network. It means, when we talk about the firewall, it means there's some fire, which is actually, and, the blockage, which is blocking your something, it will not allow you to go inside the network. It will not allow you to go inside the premises, right? It is something that which is blocking, right? Now, when you talk about the firewall initial days, in fact, in few companies are still being, they use the firewall device, a kind of hardware devices, right? When we talk about the cloud, in specifically to Microsoft, we are talking firewall as a service. Sometimes we say FaaS, firewall as a service. And Microsoft Firewall is kind of robust solution, and they also collaborate with different, you know, um, partners across the world. Like, Cisco is there, Palo Alto is there. These are the world-class network leaders. So they have the collaboration with them. So if anything which you already using in your on-prem environment and you wanted to collaborate with Azure Firewall, you can very well do it. In fact, the same firewall can also be extended to your on-prem appliances to protect them, to create a certain network boundaries. Okay. So we'll see that today when we talk about Azure Firewall, what all the components we have it. So let's understand with the concepts what we have it here. And here is the document. Let's understand the documents. All right, so it says what is Azure Firewall is a cloud native and intelligent network firewall security services that provides the best of breed threat protection for your cloud workloads running in Azure. Okay, and it is a fully stateful firewall as a service, firewall as a service with built-in high availability and unrestricted cloud scalability. All right. What does it mean? That you do not have to worry about the underneath complexity what Azure has. So it's a kind of a pass you can compare. The pass is something which means that you will be using this service, but you will not bother about what is happening inside it, right? And Azure Firewall offered in three SKUs: standards, premium, and basic. All right. Now, in the standard, what all we are going to get it. For instance, this is our VNet. And remember, guys, the firewall work on the VNet, all right, on the virtual network. So here we have a different VNet. Under that, we have a couple of virtual machines. And here we are using the firewall. So what all we can use it? We can use for filtering L3 and L7 connectivity policies. We can also integrate with our on-prem. It means if you're using hybrid environment, you can extend this solution, security solution, to your on-prem. Okay. Here, the threat intelligence, which is also known as malicious IP and FQDN, that also you can incorporate in your firewall solution, and which is a part of your built-in solution as far as your standard SKUs are concerned. Then you can also integrate the VNet and wide area network, and the threat intelligence, again, you can use it here. Then if you go for the firewall, premium has more features compared to standard. What are the features? You have a TLS inspections. It means the firewall can detect whether this URL has the TLS certifications or not. Whether the website has the TLS equipped with or not, whether it is a non-TLS or if it is having any sort of TLS associated with that. It can also filter IDPS traffic, the URL filtering, the web categories, So you can see the firewall premium has all the features which need at the enterprise level. This exploit categories, if you see that it exploit categories include malware, phishing, coin mining, and Trojan attacks. All of these things this firewall can pick it and filter it. The traffic is denied by default. By default, you cannot connect to internet, which is the default behavior. And so does here also. In standard also, same thing. Traffic is denied by default, right? And the last, basic one, you will not get all these features, but at least a kind of, small enterprise organization, they can go for it, which has the L3 and 7 connectivity policies. Still, on-prem integration is there, but you do not have the IDP, you do not have advanced threat intelligence, you do not have, couple of these features, what you can easily get it in firewall premium. The basic one will give you only these things. But one thing is very much common if you see in all the structures, in all sort of Azure firewall, one thing is on-prem integration, that you can easily get it whether you're using basic one, you're using premium one, or standard one. At the same time, the traffic is denied by default. The traffic towards your internet will be denied in any of these. So that is a kind of similarities what we have it across all the Azure firewall SKUs or the type what we discussed so far. Only the features that you're going to get it more, And of course, basis on the SKUs, the type what you're going to use, you'll have to pay more, right? When you talk about
What is this L3 to L7? Ajay?
Sorry, RK.
L3, L3 to L7.
This is a kind of layer what we have it. If you talk about TCP/IP layer, OSI layer, this work on L3 or L7 connectivity policies. We have an ISO. If you talk about ISO uh, layers, we have different layers, all together. Here it is. This is application layer, presentation layer, session layer, transport layer. So it start with the physical layer and then data link network. This is L3. A network is L3 and application is L7, we say. Okay. So all the network layer which all these devices which you talk about usually work on these. So for instance, at the network level, you can control the behavior of your overall network traffic, and it controls the network traffic at the L3. L7 is application, means I'm opening this HTTPS site. It is on your application layer. It's like it's working on HTTPS. So any sort of HTTPS, SSH or DNS traffic, it is on application layer 7, we say. So that level also you can control the behavior, you can control the traffic, you can control and set the policies. So L3 to L7 all you can control it. This layer is quite important from the network prospect, from the ethical hacking prospect, and from the security prospect. Each and every layer we have some significant importance.
Okay.
Right. Then pricing and SLA. If you see the pricing here and SLA, what is the pricing and SLA for this? So here is the pricing. If you see central US, and if I talk about central India, and if I go for INR, so for development, this is the development charges for the basic, standard, and premium. Okay. For data processing, this is the processing charges. If you are using any sort of virtual hub along with that, then this is the charges. And what about SLA? SLA is here. We need to download it for all. So there is a SLA term that we will be going to discuss. Not now, SLA and a different SLA. I mean, if I talk about, or you must have heard about that this specific service, the availability time of this specific service is 99.99% or 99.9999% or 99.69 after dot. What is the difference between this? So that we'll understand a little later when we are going to do availability index, availability set. So by default, this is your SLA for Microsoft. All the services we have it starting from September. So you need to download it. If you want to download, you can download it. Only thing is you need to provide your company corporate account ID. Sometime it will ask. Okay, it's not asked this time. So here it is, the SLA in detail. So here, as per the all the services SLA, you have it. You need to search your Azure firewall, which is here on the page number 15. So if I just search Azure firewall, so here it is. This is how they calculate uptime percentage for the month of September. Okay. And so you can see it is all okay. There's no downtime as such. And if there's any downtime, then they will be giving a kind of service credit. We will talk about this SLA part. But for now, to understand, there's no downtime as such for this month of September. And this is how actually they calculate the SLA, uptime percentage. All right. And we have the supported region. You will not get all this for across all the region, but yes, there are some supported region, but yes, in central India, you can perform all sort of practicals. And this is the high level architecture or the framework, you can say. What all that we need to do. This is the checklist, a recommendation, and a policy definition, cost optimization, design checklist. This is also needed. And then recommendation. What is the recommendation that you should be doing it? Again, recommendation for your performance efficiency. Then Azure Advisor. So these all you can go through it and understand. Okay. So what we are going to do, let's go through this. First of all, one of the here that we already understood that what all it is a firewall as a service. It is a built-in and high availability, threat intelligence-based filtering, fully integrated with Azure Monitor or analytics services, and support your hybrid connectivity. Okay. Now implementing it, before we implement, let's go and understand how we can do it in our lab. Let's try to create the blueprint, okay, for Azure Firewall Lab. Okay, so what we are going to do, we will be creating a couple of, not couple of, only one Windows virtual machine, and we'll play around with the firewall service. Okay, so we will be creating this way, and say this is my virtual machine, and I'll be creating one resource group. And I'll put it in central India. And resource group I'll be creating easy net lab. And I'll first of all, I'll see the behavior of this virtual machine. Okay. With and with first of all, we'll see the behavior of this virtual machine without implementing any sort of firewall policy. Okay. And we'll see what is the impact of NSG here. As per our understanding, we have already understood the role of NSG here. Okay. And if you recall, Azure Firewall is one of the services which actually we use it for controlling the inbound and outbound, and we can access virtual machine without the public IP. That also we are going to do today. Okay. And we'll see that how to deploy it, right? So let's go and first of all, create virtual machine. So I'm here on my portal.azure.com. So I'm here on the virtual machine, and I've already deleted all this, so I'm not going to do anything. So let's go by, step by step. First of all, let's create a virtual network. We do not want to take any chance what we happened yesterday. So let's create virtual network. I'm going to create a new resource group. I've already deleted network lab, keeping it in central India. let's say sample input. Next is okay. Now this is something that we should be doing it right away, or you can do it later on. Azure firewall is something that we should be doing it for our network. If I enable it, this will also enable everything for me. Okay. But if you do not want, you can do it little later. So we will be doing after this creation. Okay. Next is IP address. Here you can give any IP addresses. Say, I wanted to give something called 30.0.0. Okay, this is the 30 subnet I've chosen, and I'm going to create subnet also. So here I'll say server subnet. Okay, add it here, and I'll delete this one default one, and the firewall also delete it for the time being. And now review and create. Validation failed because of what reason? .30.30.10.1 31 0 and then submit. This one I need to delete. Server subnet. Still getting let me see. Let me go for C series 192.168.0. We need to calculate the subnet calculator, guys. Sometime it will throw some error message because of the internal check what Microsoft has. So better to use A class or C class subnet, or use the calculator, subnet calculator. So now it is taking. So C series I've chosen this time. I'll go ahead and create. What is that? Again, just throwing error message on this review. Is this error message? Oh. Okay. Wrongly I was chosen. This is my account. I frequently use two accounts, so the other account got disabled, and that's what we are getting this error message. So let's go ahead and create it now. It is AC net line. And here we have something called server subnet. Next is IP addressing, which is great, and 192.168.0.0, and I had the subnet also here. Server subnet. Like that, and hit on preview and create. So VNet we have created, along with that resource group we have created. Now we are going to deploy the virtual machine in this VNet, right? And we also have to deploy the firewall services. Let's deploy the virtual machine first of all. So I'm not creating any policy as such. We are just, we want to experience what is the default behavior of our virtual machine without the firewall policy. Okay. So here it is, virtual machine. We'll say VM-001. Availability set none for now. I'll say standard. This is fine. And username password. Next is this. Okay, so this is the virtual network. This is the subnet. By default, it has chosen the same. And a NIC network security group. We are going with the basic one, public IP and everything. Let's go ahead and deploy this virtual machine. Validation completed. Hit on virtual machine. Any questions, guys, so far? Anything, whatever we discuss? This network topic is going to be a little lengthy, but after this compute and network, module, I believe we are almost done with 60 to 70% of the course. The rest of module we will be completing within a couple of weeks or so. Okay, so the deployment completed. Now we can see the virtual machine now, right? Now, what is the default behavior, guys? Default behavior in sense, this virtual machine by default have the internet connectivity, right? And since we enable the port number 3389, we are able to take the RDP, and we will be able to take now, okay? Which is not the default behavior, just for information. This is not the default behavior, okay? So we'll see that what would be the significant impact when we are going to deploy the firewall here, okay? The whole idea is to just to reiterate whatever we have done in the past. It is not something the new step that we have been doing right now. We have done it in the past also, deploying the virtual machine, knowing the default behavior. So if, of course, I should be able to take the RDP now, and I've already taken it. Now, if I wanted to open the internet, I should be able to open the internet without any hiccup. And that is the default behavior. And anyone know why we are able to open the internet? What is the reason? I think we did discuss why it is a default behavior. Anyone? Guys, you're there with me?
Yes,
Yeah. Why I'm able to take the internet? I mean, why I'm able to open the web browser on the virtual machine? What is the reason?
because in policy it is not like denied. Sorry, denied, no, not blocked.
Yes, it is. Why? Because in the network, rightly said, yeah, under the outbound rule, if you see that, we already have the allow internet outbound. It is a default behavior, and we cannot delete, we cannot change anything. What we can do it, if we want to block something, we have to open a certain, sorry, we need to block the certain ports, right? All right, so this is the default behavior we understood. Now we are going to deploy the firewall to control the default behavior. Okay, so let's go ahead and deploy the Azure firewall. Simply firewall. Create firewall. So first of all, before we create anything, we have to create this subnet. This subnet we need to create for our virtual network. So what we have to do it, we need to go to the virtual network first of all, and the subnet, what you can see, this has to be the same. Okay, this has to be same. We cannot change the name of the subnet also. So let's copy it. Go to the virtual network first of all, and under that, here, create virtual network. And network name, here you can say, sorry, not the virtual network, and my apologies, it has to be subnet. We need to create a new subnet only for the firewall. It has to be for Azure. Name should be as it is. Okay, and the name, this has to be at least 26 and above, something. Okay, nothing else. Save this. Fine. Now, if we try to deploy the virtual firewall, sorry. So here, resource group, will use the same one, name. You can give anything, firewall, depth, Central India. We'll go for standard. And here we'll use a firewall policy. a new policy. So here by default, existing virtual network, this one it had chosen, and firewall policy, we need to create a new policy. We have to give firewall central basic standard. Okay. And the public IP, we need to deploy the public IP for the firewall. So we'll say the firewall public IP standard, and by default it is assigning a static IP address. Okay. Standard. Fine. Everything's okay. Basic standard. All right. Next is tagging. Nothing. Review and create. So we have just created a firewall, but it is not going to give any impactful meaning on our virtual machine or the network because we have not created any policy as such. We have just deployed. It means configuration part is you still need to complete. This will take a couple of minutes or so for the deployment to be completed, and then we will be configuring it as well. For configuring, what we are going to do, let's see that. Now, there is one more concept, guys, that we have to understand: the default root and something called system root and user-defined root. The root which we discuss, and the default behavior what you can see for the virtual machine, it is by default. It is known as system root. Okay, and the one which we are going to implement as part of the firewall is going to be UDR, user defined root, or the custom root. Okay, there's one more concept which will come in this slide. I'm going to discuss right away so that we will not be discussing again. Okay, this is like the next module for the network. There's something called system roots. What is system root? A system root direct your network traffic between your virtual machine, on-prem network, and the internet. The traffic between VMs into the same subnet. And because of this reason only, yesterday we discussed, right? If you're putting the VMs into the same subnet, will they able to communicate? Yes. Why? Because of the system root. That is the answer, right? It's not there is something called default. It is the answer because this is how the Microsoft had designed it, the system root. Okay. Between the VMs in a different subnet into the same virtual machine, also you should be able to communicate. Data flow from the VM to internet. This is also the default system root behavior. It means it is by design. You cannot change this, right? But yes, you can override it by creating a new policy or the new rule, but you cannot delete or modify this specific system root. Communication between VMs using VNet to VNet VPN, that is also possible. A site-to-site express route communication through the VPN gateway. These all are possible because Microsoft has designed in this way only. This is the system root. You cannot do anything on the system root, but you can always override it. Okay, guys, you can always override these settings. How? Using this UDR, user defined root, or sometimes we say custom root. In that, we have to change the root table, which has a set of rules called root, and specify that where you are going to make the changes. For example, now in this firewall practical, we are going to change the default behavior. We want every sort of traffic should go through the firewall now onwards. So we are going to change the behavior of this. This is going to be custom root, or we say UDR, user defined. Okay. So this actually define a kind of root, and it is being controlled by the custom root or the custom appliance that we are going to deploy. Okay. The next hop can be virtual network gateway. It could be network gateway, internet, or the virtual appliances. And what do you mean by hop, guys? Anyone? What is hop here? HOP. What is HOP, guys? Anyone? Yes, no?
Means move forward, like one step move forward, one
It
virtual
is
network.
similar to that. Yes, pretty good. It's just like, if you, it tells you that what would be your next hop. It means next step. For instance, if I press search, there's a command for google.com. It is my local machine, and I'm trying to connect to Google. So if I try to connect to Google, how many hops I have to cross in order to connect to the google.com? So MS is nothing but your millisecond. So from my local system, it goes to my router, then my ISP, then the Google internet facing IP address. Sometime it will be ICMP will be enabled, so I will not be able to track the IP addresses because of the security reason. But in fact, to connect to the Google, Yahoo, Microsoft, how many hops, how many steps I need to go through? That is the hops. So you can see to connect to the Google, now it is coming in 4 millisecond, and these are the steps. Now my ACT broadband is there, so now it has connected to my ISP, and from there it is going to Microsoft, Google. So this is okay. This is the Google IP, and to connect to Google, I have to go through these many steps. These many hops are there, 11 hops. Got it? That's what it says. The next hop can be a virtual network, gateway, virtual network, internet, or the virtual appliances, right? This is all about user-defined root. So we will be actually implementing this UDR. That's what I wanted you to understand this concept. Are we clear with this, guys? Any questions? All right. So I'm coming back to the portal here. Deployment is ready. Now under the firewall manager, sorry, under the policy. Here is the policy, right? This is the policy. But before we go here anything, we have to change the default behavior of our network. Right now, the behavior, what you can see, I am able to connect to this internet. I'm able to connect to the virtual machine because I have allowed 3389 in NSG. And default behavior is I'm able to open the internet. So I'm going to override this by changing the system root table. Okay. Just try to understand, guys. I'm going little slow. At any point of time, you need to have any sort of questions, you need to have some more clarity, you can ask, because they're lengthy steps, but you can always refer the recording if you wanted to do in your lab. But please pay attention here. Okay, so I'm going to change the root, default root. So here we'll search root. This is the root table. Okay, right now there's nothing. Okay, we'll go ahead and see. Okay, one more thing. Actually, let me open the duplicate tab here. I need to copy the public firewall public IP and private IP both, because those both I need it. So I'll copy the private IP. Okay, and also need the public IP for my firewall. Okay, so I'll see where is my public IP. This is the one. We'll copy it. Okay, now let's go ahead and create. We have to use the same resource group. Reason is same, and we say something. You can say the root table, something. Then next is this, next is this. So we are creating the table. Create. And then go to resource. Here it is. And now under that, we have something called subnet. And then we need to associate the subnet. All right. So here we need to select server subnet for now, because we want to change the behavior of the server, what we have it, and all the subnets, all the servers which are part of this virtual network. So I have chosen the same. Click OK. Then select the root. These two changes we need to do. And here we can give any name, for example, firewall root and destination. Here we have to give the destination for the IP addresses, and we want every sort of traffic to follow the firewall. So here we will be giving all the traffic this way. Of course, you can give any IP addresses. And the most important part here, the IP address. Here we will be giving the virtual appliances and the IP address. Here we will be giving the IP address of our firewall, which is going to be private IP address. And we already noted down. This is the IP address. Copy it and paste it over here. All right, and click add. So what we did by following these steps, we have changed the default behavior of our virtual machine. Okay. So now every sort of things, in fact, all the incoming, outgoing, everything is being controlled by firewall. So if I refresh it, and if I try to connect to the virtual machine, see what happens. I lost the control. This is in caching. I'll just close it. And now if I go to the virtual machine, try to take RDP, see what happens. Okay. I've not made any changes to virtual machine, but I'm not able to take the RDP. Why? Because now everything is being controlled by firewall, right? The firewall is taking control now. It has taken the control, in fact. Okay. And by default, if you recall, by design, the firewall is blocking all sort of internet connectivity, all sort of inbound and outbound connectivity. And since we already implemented the firewall, the virtual machine, what we were able to take the RDP, we are not able to take. Are we getting this point, guys?
Not exactly.
Yeah, okay.
Not exactly. Ajay, can you please come again?
Yeah, sure. Okay, let me demonstrate here. This was the virtual machine. Okay. Before the firewall, anything, whatever we deploy, let's remove the firewall. This is the default behavior of my virtual machine. Okay. When I say the default behavior, actually what we discussed, this is something called system root. Because of the system root, because Microsoft has designed the way it is that you can connect to, by default, virtual machine can connect to the internet. By default, all the VMs which are part of into the same subnet, they should be able to communicate. So that is a default behavior. So when we connected to the virtual machine, when we deployed the virtual machine, what we did, we tried and checked, this virtual machine. First of all, we were able to take RDP since we had enabled port number 3389 in NSG, right? That's the reason we were able to take the RDP. The second, we were able to take, or we were able to connect to the internet because that is a system root behavior. Till here, all clear? RK and everyone?
Yes.
Okay. Now, what happens when we change the system root? We change this was the situation before we deploy firewall, right? Post deployment of firewall, what we did, we first of all changed the system root. That is called now, that is known as UDR or user defined root. We change the behavior of the system root by changing the root table. And we instructed that every sort of traffic, whether it is inbound or outbound, for this virtual machine, what we created here, every sort of inbound, which is coming towards this or going towards this, everything should be controlled by our firewall. Everything should be controlled by the firewall. So the firewall is the main control mechanism now. Whatever you're trying to do, because what we did, we changed the root table. We override the system root settings by changing the root table, and we specifying that every sort of traffic should go through my firewall. And by design, the firewall is blocking everything. And that's the reason you're not able to take RDP, and you're not, of course, you will not be able to connect to internet also. Now, one good thing that you should be noticing here, that though we enable the port number 83389 in NSG, but since the traffic is overriding or firewall is taking control of the entire network, NSG is not able to do anything, because firewall, because of the firewall setting, firewall is overriding and taking the control. NSG is nothing, because on the network level only the firewall has stopped everything. So though you open it here on the virtual machine level, you're not able to take that. Is it clear now?
Yes, Ajay.
So this is the behavior of the firewall, but we are still not done. We are still not done with the practical. Now suppose you want to take RDP, right? You want to take the RDP. So what you have to do? Now we have to create the policy in the firewall, right? So let's go ahead and create the policy, because the policy by default, we have not filter anything, we have not filter anything. So to filter it, we will be doing this policy rule. So let's go to the firewall policy right now. Here it is. Then we overwrite firewall policy, and here it is, this one policy, and there are plenty of policies here. All right, since we have chosen the standard, you can see we have IDPS, we have TLS inspection, we have a threat intelligence, DNS, application rule, network rules, DNet rules, and plenty of rules. We can play around with it. So the one which we are going to do, we will be creating a DNet rule for our RDP. So let's create the rule connection. And here we'll say allow RDP. All right. Rule collection DNet. And again here, the same concept, what NSG has. Lower the priority, higher the precedence. It starts with 100. So you can give any number here. Say I'm giving 500. Rule collection should be DNet. And here we will be giving the same name. Now this is also critical to understand, guys. And I'm going to open the virtual machine here. Okay. And here I need the private IP. I need only the private IP, right? So it is. So IP address, source IP address, source address. So here we can give the source IP. Let's select the IP addresses. Under the source type, we can give anything for now. Let's give asterisk, protocol TCP, and then destination port. Destination port should be 3389, because this is what we want to control. If it is a Windows, if it is Linux, then it has to be 22. The firewall IP address, see here, PIP, it means your public IP address, and we have already noted down. This is my public IP. I'll copy the public IP for my firewall, right? I'm not given any IP address so far for my virtual machine. Okay, then there is something called translated IP address, which is here, and translated address for here, port number, again we have to give 3389, and the IP address which we wanted to connect. and that is going to be my private IP address for the virtual machine, and paste it over here. So in fact, what we have done, it is also known as netting. We have done the netting here, network address translator. Okay, let me reiterate the step. What we did, we created the name here. Source is let it be asterisk. It means all of this. Protocol, what we are focusing is TCP. Destination, which means the port which we wanted to allow, right? 3389. And where we wanted to allow on my firewall public IP. And underneath, whatever the packet will flow, that is my private IP address of my virtual machine. That's it. And then add.
You want a private IP, Ajay?
Sorry? Come again.
Why only private IP?
Because we created a translator IP address, because we do not want, remember, one of the practical is still pending where we want my virtual machine to be able to connect using the private IP address. We do not want to entertain public IP. So the traffic will go through the firewall public IP, but inside that, my private IP address of virtual machine will be there. So once it is done, we'll see in a real time how actually it works. So we use the combination of public IP plus the private IP. Since the firewall, is interacting with my internet, the public IP is must. But for a virtual machine, it is not needed. Okay, successfully done. Now you come here on the virtual machine. Now tell me guys, what would be the behavior? Will I able to connect to this virtual machine? If I try to connect?
Yes.
Okay, let's see that. Now we need to figure it out why we are not able to connect. Are we doing something wrong? We are not able to connect. Now, this public IP, which is associated with this virtual machine, making no sense to us because we are not able to connect, right?
Right.
So what we can do, we can remove it. We do not want this IP address. Deassociate from the virtual machine. Okay. So now this virtual machine has only private IP address. Okay. If you see that, and refresh this. Okay. Public IP has gone. It means what? I have only the private IP. So now, will I able to take RDP with the private IP?
Yes.
Okay. Let's see that. I'll take some water guys.
Private IP, maybe no, I feel. Sorry.
Think, guys, what we did in the firewall.
Private IP, I think no. As we are not in the same network, we won't be allowed.
Right. Now, let's see that. This public IP is what? It's my firewall public IP, right? So let's try to connect and see the result. This is my firewall public IP. Okay, connect. And so I'm connecting where? On the same virtual machine. But using what? Using public firewall IP address. And I'm in to the virtual machine.
You are connected with the public firewall IP to the virtual machine.
Right. This IP is belonging to what? Where? 20.219.56.180. This is my firewall public IP. Remember? This is the firewall public IP, which is here. 20.219.56 and 180. See here? Same IP.
What is this IP of the machine?
Machine IP address is this IP address, 192. And we do not have any public IP associated with this virtual machine.
Correct.
We have the private IP address associated. So why it is happening? Because we have created a policy. We have created a policy, and this policy is saying that you should be able to connect this policy under this. Let me just tell you the configuration again. This is the one. Here we have given a destination IP address. It means my firewall public IP. And then this is the port, which is the 3389, since it is a Windows server. Then I'm saying translated IP address. Inside the firewall, I'm giving the translated IP address, which is private IP of my virtual machine. And I'm saying on this port, you should be translating this. So in fact, now if you are trying to connect, if you are trying to connect, you guys wanted to try it. So for that, I have to give you public IP of my firewall, which is again this one. So if you connect to this, you should be getting the prompt. Just give a try. You should be getting a prompt for my virtual machine.
Yes, I'm getting the prompt. I'm getting the prompt, Ajay.
Yeah. So you're getting the prompt. It means you're able to connect to my virtual machine. If I give you the credentials, you should be able to in. Right?
Right.
So that is we completed one of the practical. It means everything is being controlled by firewall, and every sort of traffic is going through the firewall. And we can access our virtual machine using the private IP. Okay, using this private IP. Of course, in the backend, public IP is being used, but that is for firewall, not for our virtual machine. So we do not need the direct public IP to be associated with our virtual machine. Clear with this theory and practical guys?
Yes, yes.
Okay. Now there's one more thing. I'm into the virtual machine. Here it is. All right. Now again, I'm saying that everything is being controlled by firewall. So does it also control the behavior of my outbound? What is the default behavior of my virtual machine? Outbound, guys. Outbound. I'm not saying inbound. That I should be able to take the RDP and I should be able to open the internet, right? That is a default behavior. Now, if I am trying to open now any internet or anything, any website, Google, it's not opening. Microsoft, it's not opening. LinkedIn, it's not opening. Because again, firewall is controlling me, controlling the entire network, right? It is controlling the entire network. So assuming that if someone need this website, right, on the specific virtual machine or the network, then you need to create the policy again, and this time the policy will be application policy. And here we will be assigning and letting firewall know that yes, this is the policy that you should be creating for us. So let's go ahead and create one policy, and let's allow only the Google, allow Google application. Again, this has to be anything you can give 300. Allow, it has to be application group. Okay, and here you have to give source, select IP address, and here the source type you can give IP address. Protocol, here you can give protocol HTTP and HTTPS, and the target you can give here FQDN name. Here you can give like FQDN name, something called www.google.com. Okay, and here you need to give the source type. The source type is going to be your that
Our private IP?
private IP of that virtual machine, correct? All right, this is what we have to give it. Let's verify on, allow Google, IP address. HTTP and HTTPS for the protocol we want, FQDN, and just add. Okay, wait for some more time to reflect this policy, and then we'll see the behavior. Any doubts so far, guys? Of course, the practical is a little lengthy, but I'm trying to, going to make it very slow and I think the pace is quite okay. And if you still have any doubt, please go through the recording and try to implement in your life. Okay, and that's it. Let's go to the virtual machine, close everything, refresh, open the browser again, and let's open Google, and we are able to open Google. Okay, but are we able to open any other site? No.
In Google, search something.
Okay, we search, say, Facebook. Okay,
If you open that link, it won't work.
it will not work. We have just allowed the Google. If you try to open Facebook, it will not. It is India Times. All of this will not work because we have not allowed. We have just allowed the Google. Okay. So
These
if you
are similar to our inbound outbound rules, right?
sorry.
This is similar to our inbound and outbound rules.
Yes, yes. Of course, it control your inbound and outbound both. The firewall is boss. It's controlling everything. Okay.
If you want to allow everything in the internet, maybe
Then
only
you have to
HTTPS.
allow, yeah, you have to change asterisk here. Instead of Google, you have to type asterisk. Asterisk. It means everything.
Right.
Everything. Then it's not making any sense, right? Then what is the use of firewall? You select only selected website you can allow. You should allow it. If you're allowing everything, then the use or the purpose of the firewall will be defeated, right? You don't need anything then. The firewall itself you don't need. Why we are using the firewall? To control such, malicious website. Everything will be blocked, and whatever the website you wanted to allow, you allow it here.
Sometimes in the corporate offices, we get right. We will get an alert saying that it is not a safe website. Do you want to proceed?
No, that is being controlled by URL filtering of your mailing system, email system. Usually, you should be getting on your Outlook, or sometime if you have any kind of URL filtering. There are different, I would say different products are being used. For instance, in our company, we're using Mimecast email gateway system. Okay, on top of it, we're using Netscope. So these things are being controlled. Like if you're trying to open any website, instantly you will be getting one message saying that this is not safe. Still, you wanted to continue, or sometime straight away it will be blocked, right? So all of these things, because we are using the different security system in place. It is nothing to do with the firewall. But yes, in the firewall also we can configure, like, threat intelligence is there. We can configure that. We can also use the TLS inspections. The TLS part, which is this one, you can configure that, okay, TLS policy, of course, right now it is not available, but you can configure is a part of your premium. IDPS, that is also premium policy. You can configure here threat intelligence, anything like from the specific subnet or the IP range. If you wanted to receive, then you have to allow it here. So the corporate, we use multiple things, but here on a network layer, we are using these firewall for now. Clear, guys? So that's it, the practical for the firewall. We can, if we want, we can enable multiple website. And if we do not want, then we can just remove all the website and put it only the asterisk symbol, which will allow everything. But again, you will not allow for everything everywhere. You will be having at the network level, you will be having different segment. For instance, for the finance team, you wanted to put more security restrictions. So for them, you will be creating a different VLAN, and for them only you will be creating a different policy. And for marketing team, because they wanted to communicate with the internet, they wanted to be on a social networking site as much as possible. For them, internet is must, because this is how they are going to bring the business for you, marketing sales team. So for them, you will be having different policies, right? So that way also you can bifurcate policy for the different department for different people. Clear, guys? Are we clear with this concept? Right.
Right.
Yeah, sure. So we'll just take 5 to 10 minutes break, guys, and then we'll assemble again and we'll complete the rest of other theory and the practical, which is like nothing but your Azure DNS. Okay. So it is 9 o'clock. We'll assemble again at 9:10. Okay. I'll start the timer. For reset. Wait, let me change it to okay. See you guys in 10 minutes. Okay. I'm back, guys. Let me know when you are there. We can start. Can we start, guys? Everybody's back?
Yeah, Jay.
Okay. All right. So first of all, let's understand what is the DNS. Okay. I hope everybody must be knowing it, but let's quickly recap. So what is your take, guys? What is DNS?
Domain name service.
Mm-hmm.
So if we give some name, uh, uh, I may not be explaining well.
That's fine. That's
Sorry.
fine. So we are discussing here DNS. In actual, it is domain name system. Okay. And domain name system. It's there since long time. It's not something that we are discussing right now. But why the DNS comes into the picture? Let's understand that concept first, and then we'll come back here on the DNS. Almost a decade ago, when we talk and discuss, this seems to be, before the DNS, there used to be something called work group. And there we used to have something called individual system. And suppose I want to connect to your system, so I need to have some kind of connectivity. Actually, it will take us to the different direction, something called Active Directory. But I don't want to get into that topic for now. But I'll be giving you some flavors to understand. So for that, we have something called work group, and then the domain join system. But actually, DNS is the prime component for the ED also. So when we talk about DNS, what actually it does, it works as an intermediate. You know, we as a human being, we can easily remember the name, but we cannot remember the IP address. And being a machine can easily understand the IP address or something called binary 0 and 1, but they cannot remember the name. To sort out this problem, only DNS is there, which actually convert the host name to IP and IP to host. As simple as that. Suppose if we can easily remember google.com, microsoft.com, linkedin.com, facebook.com. Suppose if we have to remember this number for Google, we will not be able to do it, right? It's kind of highly impossible for us to remember. That's what the DNS comes into the play. Okay, that is called the DNS, domain name system, which actually plays a intermediate role, convert the host name to IP and host IP to host. Okay. So we have different a kind of servers type here, like recursive servers, root name servers, and then authority name of servers. So these are the different type of servers we have it commonly used by. And then we have a different type of DNS queries. The DNS queries, when we talk about, because that also we need to understand DNS queries. We have a different set of queries. Our first one is recursive query. Recursive query. Because recursive queries. What does it mean? It actually keep on querying the from the server to the next server unless it find it is satisfactory answer. It could be in the form of full name, or it could be any sort of query which is needed unless it found the solution. That is called recursive query. It usually happens between your server and client. And then we also have something called iterative query. This iterative query DNS query, and this takes place between recursive resolver DNS server, which is nothing but your local DNS server, and non-local DNS server. For instance, if I'm the client, is the I'm the user, for instance, and suppose I want to reach to google.com. Okay, so what is that process? It will connect to my nearest server, whatever the DNS server I have. So this is my server, DNS server. So it will first connect to this to resolve the query, and the server, suppose this server does not have the answer for this, it will connect to the nearest server, nearest public DNS server. So for this user, this server becomes the local DNS server, and this is going to be your public DNS server, which has the public information, which has the information on the Google, LinkedIn, and all, because that is as per the design. Okay, so the moment user is trying to access google.com, microsoft.com, it will query to this local server, and if suppose local server does not have answer, it will connect to this server, and this process will go on, which is called iterative DNS query, unless the client will find the satisfactory answer. So that is very much common in the DNS world. We have a recursive query, iterative query, and the common DNS records. We also have some common DNS records. And what are these? That also we need to understand. These are the DNS records, what we usually can be present in any of the cloud on-prem data centers. We have something called A records. The A record is nothing but usually, it will be having IP version 4 and IP version 6 also. For A record, if you see that it has the IP version 4, which hold the IP address of the domain. It means it will hold the IP address of the specific domain. For instance, if I say abc.com. So while creating the record, you will specify that, okay, for abc.com, this is going to be my IP address. . Okay. Similarly, there is something called AAA records, which hold the same host name to IP, but this will be for IP version 6. DNS itself is a very big topic, guys. It's a part of your MCSC and Active Directory DNS and all, but I'm just trying to keep it short because these are the fundamental parts. Once you get into the Azure DNS, the concept will remain same, but you should be able to correlate this concept there as well. Then we have something called TXT records. TXT records is nothing, but it enables the administrator to enter text into the DNS. And these TXT records you will be usually exchanging while registering your domain. For instance, suppose you purchase one domain from GoDaddy, Big Rock, or any other service provider, and you wanted to utilize it in any of the cloud service, whether it is Azure or AWS, then you will be exchanging these TXT records. Okay. Then fourth one is we have something called CNAME, which is nothing but your canonical name records. Canonical name records is nothing but suppose one website is known for example, you have Microsoft.com. Then at the same time, you have Microsoft.co.in. Then you have Microsoft.co.nz or AU or US. So the parent name is the same, but you wanted to create one more child name or some other website, which is actually redirecting to the same website. For that purpose, we will be using the CNAME records. Okay. So these are the couple of things that we should be knowing it. And then we'll just switch to the Azure DNS. So when we talk about Azure DNS, the Azure DNS is nothing but the same concept here. Here again, we have the same concept. It means you will be having the different set of DNS records, the way we have it, and then you can create a custom domain. Now, if you see that by definition, these are the DNS what we discussed just now. Azure DNS, what is of course, the functionalities is going to be same what we discussed, but it is like everything is being managed by Azure. That's what it is, Azure DNS. Okay. It's hosting services for DNS domain that provide the name resolution by the Microsoft Azure infrastructure. For instance, this is your VM01, right? But it does not have any sort of DNS configure. If you see that, there is no DNS. So the name resolution right now, we have only one virtual machine. But if suppose you have a bunches of machine and you wanted to give some, meaningful name, so it has to have some sort of DNS records to interact with other resources, to interact with other virtual machine. And it has to have the IP addresses. The IP addresses. So this IP address and this name has to be registered somewhere in the DNS, right? So by hosting your domain in Azure, you can manage your DNS records by using the same credentials, API, tools, and billing for the Azure services. However, you cannot use Azure DNS to buy a domain. There is no facility as such. You want to buy the domain, please go to godaddy.com. From here, you can buy the domain, any domain, but once you buy the domain, you should be able to integrate. You should be able to integrate. The buying facility is still not there with Azure DNS. Okay. Reliability and performance wise is also Azure DNS is good. Security, these are the different security parameters what Azure DNS has. RBAC, activity, resource locking. Then Azure DNS also support your, sorry, it does not support your dynamic secure DNS. Okay. And this is the pricing. And then these are the alias record. Alias records is nothing but again a CDN records. Okay, this is like different short, the different sort of alias records what we have, what we discuss. These are the A record 4 times A. It is not 3 times A, guys. My bad. Here is a 4 times A for IP version 6, and then we have a dangling DNS records and all. So the intention is if you wanted to play your VMs with the IP address, you can very well do it by establishing the proper Azure DNS records. Okay. So let's see how do we create the DNS records and the DNS things. For instance, these all, let's go to the practical here in our lab and search the DNS. Okay, a very first thing which you will see that DNS job. This is something that you should be creating. Azure DNS is a hosting service for this, and you can create the DNS job. So if I create it, from here, I'll be creating something, the name. So here, the name of the DNS which you wanted to create. For instance, I can say contoso, okay, .com. Something, some meaningful name. Of course, the domain name you will be giving it. Or if you already have some domain registered, then you should be giving the child name. For instance, xt.contoso.com, something similar to that. Then next is tagging, and then hit on review plus create. So deployment completed. So now if you go here, you will be seeing here, by default, you have some name server and some, authority records. This is being provided by Microsoft. Now from here, you should be able to create a different record set. You have these name servers. This is like by default, Azure has given to you. From here, you should be start creating the records. And these are the different set of records, what we have in Azure. A records, and again, IP version 6 records, certificate authority, CNAME, mail exchange, name server, SRV, TXT, PTR records. All of these things you start creating. Now, for example, your VM name is VM01. Now, this you wanted to create, and you wanted to give the domain name also. You want later on you wanted to join this machine to the domain. Then you should be creating this here. Manually, you should be creating it, or the moment you're joining the domain, if it is a Active Directory or something, then by default, the A record will be generated for this machine. Similarly, any application which you wanted to deploy any application, that application A records, DNS records, any changes which you wanted to do, you can do it from here. Then you need to specify the IP address. For instance, let's create this A records. IP address, here is the IP address, and the name. Here you will be giving the name, and this name can be different, guys. This name can be different. You can give any meaningful name. Click OK. So A record has been created for me. Like that, you can create a multiple records. Then you also have something of properties. Under that, you will be having the location. By default, the location is global, and maximum you can create. See here, a 10,000 record set you can create in one DNS job. Similarly, you can also create any child domain. It means under contoso.com, if you have any other domain, then also you can create it. For instance, if I say XYZ, so it will become xyz.contoso.com. So the parent will be contoso.com, and under that you will be having one more child domain, xyz.com. Rest of other things will remain as it is. Okay, so that is also possible. This is how we create the DNS. That's what we saw, that DNS, then DNS tickets, and then finally DNS for the private domain. Now, what is that DNS for the private domain? Like, if you wanted to have your custom domain, for instance, of course, this is a hypothetical domain, but if you wanted to have your custom domain, you will be creating a custom domain. Suppose you have already registered the domain which is publicly exposed, then you will be using that DNS name here. So that is something that we should be knowing it. The role of the DNS here is like two things in practically. One is you will be using for custom domain. Mainly it is being used for the custom domain. It means any domain which you wanted to onboard for your for instance, the company name xyz.com. You wanted to own this domain. You wanted to create the DNS for this domain. You wanted to have the certificate for this. So all of these things you can integrate with the Azure DNS. You can manage this domain with Azure DNS by exchanging the TXT records. And how do you create this? Actually, my Azure AD is having some problem, so it will not open. But here you should be creating something called custom domain. Here it is. Okay, for instance, I've already created this, which is I don't have access because of some reason. I'll be using a different subscription. But here, if you see your free tier account, you will be having custom domain. You will have to select custom domain from here or add domain. The moment you add it, then you will be prompt. Let me see whether I should be able to toggle it here. But again, it will not be visible. Yeah, there it is. Instead, this one, I can create any domain. Say abc.com. Okay, add domain. But is it like creating is something that it has to have some meaningful name. You can't just create any XYZ or any domain just like that, because that is the reason your TXT records comes into the play. These settings you will have to, from where you purchase this domain, you have to give this setting to them and ask them to exchange the TXT records. Once they create the TXT records, then Microsoft will do the proper validation whether this domain is legit one and you are the owner of this. After completion of this validation, your domain will be live. Otherwise, it will be under verification, validation, like that. You will be getting the prompt. This process will take.
Is the MX here, Ajay?
Sorry?
MX.
This is for mail exchange records. One is TXT. This is for ownership check. This is for mail exchange. Suppose if you for this domain you have some mailing server, exchange server. or for Azure Ready integration. For that, you will be using MX records. Usually we use for TXT records. Yeah, Priya, you were asking something.
No, nothing.
Come again, Priya. You were asking
No,
something.
nothing. I'm not asking.
Your voice is quite low.
No, nothing. Is it fine now?
Yes, pretty much okay.
Yeah.
All right, okay. So these are the different domain guys. Okay, and let me delete it. There's nothing I should be doing it. Well, let me go back and switch to my subscription. So this is all about your Azure DNS, guys. Okay, we will be creating the DNS. We will be creating the different set of records. We will be, going ahead and integrating with our custom domain. All of these things we can easily accomplish. And finally, we will be having something called private zone. Now, private zone is nothing but suppose you have some storage services. You have some services which you wanted to create only for a specific DNS or set of IP or set of virtual machine. For that purpose, you will be creating the private zone. Then you will be assigning that, okay, these number of people, these number of machines should be able to connect to any specific set of services. Say storage is one of them. So for that only you will be creating the private zone. So that's it. The component segment one of the network part is completed, guys. We are almost done with this. So let me quickly go through the segment part two. And in the part two also we have covered custom route. And here what we have covered system route and custom route and routing table and all that we already covered. Now there is something called service endpoint, and then we will be jumping to the load balancer. Okay. Now service endpoint is what? As you can see, the service endpoint limit your network access to specific subnet and IP addresses. Okay. Improve the security as a whole. Optimal routing for the Azure service from your virtual network. And simple to use for the less management. For instance, these are the, as you can see here in this diagram, this is my virtual machine and I'm creating one service endpoint. So it will not connect to internet. There's no connectivity for the internet, but by establishing the service endpoint, I'm able to access certain, account or say some storage account. And this storage account should only be accessible from this virtual machine. And people who are connected to this virtual machine should only able to connect from here to here. So all these things can be accomplished using the service endpoint. So by default, there are plenty of built-in service endpoint like Azure Cosmos DB, cognitive services, your storage services, SQL services, Microsoft Web, all of these things you can leverage it. It's just like endpoint. You do not need to create any virtual machine over the internet. The endpoint, the beauty of this endpoint, creating the endpoint is the traffic will be there inside your network. I mean, inside your network instance at your Microsoft level. Okay, the traffic will not go beyond your Microsoft bank. For that purpose, we will be creating this endpoint service. Clear, guys?
Yeah, Jay.
All right, okay. So now we'll switch to the load balancer, guys. This endpoint, we will be doing it, the practical, when we are going to do the storage part. Okay. Now let's move to the load balancer. Now, what is the load balancer? How many of us heard about load balancer?
Uh, Maybe what I heard, what I understood is correct or not, but just when there is a it's maybe we can call it kind of scaling. Whenever there is a when suppose we are running an application and whenever there is a huge load coming in and it will be balanced in 2 machines or 3 machines.
Okay,
Yeah.
and why do we use the load balancer?
Why do we use means to make sure that website doesn't go down due to this traffic and all.
Yeah, actually, to balance the traffic, and if suppose one endpoint is down, we can still access the service using this load balancer in a different location or from the different endpoint. For that purpose, we will be using the load balancer. Okay, and if you see that the prime objective of the load balancer is to load balance your traffic. The traffic has to be load balanced. It is not something that one server has to be highly loaded and another server should be lightly loaded. There's some should be there's a behavior analytics. Nowadays we say as part of the AI that has to be there. And nowadays the load balancers are quite intelligent. They know when to redirect the traffic, when to stop the traffic. Of course, all these settings you need to configure it. All right. So let's see how do we in Azure, how many types of load balancer we have. In Azure, when we talk about load balancer, we have a different set of load balancer. It start with Azure load balancer, we say. Then we have something called traffic manager. Then we also have something called application gateway. And finally, we have something called Azure front door. These are the 4 types of load balancer we have it in Azure. Okay. So we'll go to each and every module and we'll try to understand insight of the load balancer, and we'll end of the day, finally we'll do the practical. Of course, the practical will go hand in hand, but end of the day, when we are going to conclude this topic, we'll understand in which circumstances you should be using this load balancer and what is the significant impact of using load balancer and how actually it is differ from one to each other. We will be doing the table to table comparison again to understand the overall picture of the load balancer in Azure. Okay. So for now, let's go and understand the first kind of load balancer, which is known as Azure load balancer. Okay. Now, Azure load balancer. This is the load balancer overview for Azure load balancer. So if you see that the load balancer, what we have it here, it can be used for inbound and outbound traffic. And there are 2 kind of load balancer, public and internal. Or we sometimes say public or internal or internet, two kind of load balancer. So the one which we use here on the screen, what you can see, this is your backend tool, okay? And you're using the load balancer here. So if you're using a backend pool and that load balancer is not connected to any sort of internet, it's not connected to any sort of internet, and it is balancing the health and rule for your backend pool or the servers, then this is known as internal load balancer. Okay, it is known as internal load balancer. One such example could be your SQL server. SQL server normally they do not communicate with the internet, right? They don't need the public internet connectivity. So if suppose you're using a load balancer to load balance your SQL server, that is something we can call it as an internal load balancer. Okay. Usually the role of load balancer is distribute the incoming traffic basis on the rule which we configure on the load balancer. Let's understand some more theory here. As you can see here, internal load balancer. What is that? First of all, understand this one, public load balancer. Now, public load balancer is something you're mapping your public IP address and the port number for incoming traffic to the VM private IP address and port number and vice versa. Here you have the public IP. It means you have some web server or the web server subnet you need, and you have some few virtual machine as part of web tier. So you can see that you can apply the load balancing rule on distribute the traffic across the VM or the services, which is your public load balance. Okay. At the same time, we have the internal load balancer. For example, the SQL server, which we spoke about. You have a SQL server, 1, 2, 3 servers, and on the front end, you have the VM. So for balancing the SQL server, you are using the internal load balancer. Are we getting the point, guys? Are we getting the disturbance between internal and external load balancer? Don't worry, we have the practical also lined up. We will be doing the practical as well for all of these. So things will be clear more. But for now, just focus on the theory. Okay. So these are the two different set of load balancer by default Azure provides. And of course, you have something called SQs. SQs, again, since beginning we have been talking, it is nothing but a kind of features that you're going to get it. The more SQs you're going to add it is like basic, standard, and premium. The more features you're going to get it. And of course, accordingly, you need to pay the more. So for now, you can see standard load balancer can span between two virtual network. The basic one does not support your load balancer SQs. And it supports your both basic and standard SQs, load balancers. Then we have something called backend pool. What all you can add it as part of your backend pool. As a single VM also you can use, or VM skill set, or the app services. Also you can use the backup pool. These are the load balancer rules that we will be doing it, and we have to configure it. So I'm not walking you through. Now there is something called session persistence. Session persistence is what? It is the client and your IP. For instance, if I'm the user connected to one of the server, so next time onwards, if I configure this in my load balancer and if I want, a certain set of people should be able to connect only on one virtual machine because that virtual machine, okay, let me try to create a diagram here. So we are talking Azure load balancer. Under that, we are talking the session persistence. Okay. So session persistence means what? Say I have my load balancer here. This is my virtual machine, set of virtual machine 1, VM1, and VM2. And it's connected to one load balancer. Load balancer, and say I'm the user. I'm the user, and so this load balancer has some website which is called marketing.com. Okay, and marketing.com is actually configured on both the virtual machine, and load balancer is something that which is controlling the behavior. Now, when I enable the session persistence, for instance, a very first time when I connect to this website, which is configured on the load balancer will redirect the traffic depending on whichever the server is available. It will redirect the traffic. Now, in the scenario 2, when we enable the session persistence, we want to capture the client IP address, protocol, session ID, and we want every time if the user requests to connect to this website, every time it has to connect to this server every time, because I know this server is quite, the configuration of this server is quite heavy. It means it can take more load, and this set of people, probably this user, another user, they are the VIP users.
Sorry, Ajay. Sorry to interrupt you. I have to step down.
Yeah, we are just
Thank you.
about to finish in 5 minutes. You can stay or you can step out, no problem.
Thank you. Thank you so much, Ajay.
No worries. Thank you.
Bye.
Bye-bye. So guys, these are the set of people, these are the set of users to whom we need to connect, and we want to have the, special privileges or the gravity every time they should be able to connect, and they should be redirecting to the VM02. If that is the case, if you're looking for, then you need to enable the session persistence. This is the way. Client IP address will be handled by the same virtual machine, client IP and a protocol. So once you enable this, every time user will connect to this specific virtual machine. And then we need to create the health prop. And under the health prop, we will be configuring that what would be, the health for the virtual machine. For example, load balancer is the component which will go and knock the virtual machine and ask the health, stating that, okay, are you okay? Are you okay? For example, the neighbor, if you get something, someone is not coming out from the room, or you see that, okay, someone is not there. Of course, in the flat culture, it is very minimal nowadays, but yes, say your family member, if suppose he or she locked himself or herself in the room, and all of a sudden it happened, then being a well-wisher, you will go and ask what happened. you know you will knock 1, 2, 3, 4 times just to see if everything is okay. If you if you get a response from your neighbors or your family member that yes, I'm okay, then you will feel relaxed. If not, then you will feel something is not good, then you start taking some sort of action. Similarly, in the load balancer part, load balancer will go and check it out whether if everything's okay. In every 30 second or 20 second or 10 second, we can create a probe. There is something called probe to check the heartbeat of the server. If the server is fine, then it's all okay. If not, then it will declare as a dead. Okay. And it will need not consider for any sort of request. So that is called health probe. So all of these settings, all of this configuration, we will be doing it in our next class, guys. All right. So with this, let's conclude it. Unless you guys have any questions, we are all set to wrap up. Any questions, guys?
No.
All right. Okay, fine.
Yeah.
Fine, guys. Then we'll meet next week. Till then, take care. Bye.
Okay, bye.
Okay.
Thank you.
This recording will be uploaded by noon. Okay.
Yeah, sure.
Thank you.